So I'm Chris Dancy at Bucknell University, as Christian just mentioned. My email, my website, updated about as much as any academics website is updated. And also, if you happen to be into it, and it can be actually really useful, Twitter as well. You can follow me on Twitter, Prof. Dancy. So I'm going to try to stay in time as much as possible so that we can get to the final panel and people can go about their day wondering more questions towards the end of this symposium. So I wanted to start this talk with kind of an example of thinking through some of the but why and regarding that title and going from physiology to social perspectives, which is fun. So let's say we have developer Kelly. Developer Kelly is developing this AI they've come to call NODS. And traditional way of thinking about it, or where we might start, might be that you want to understand and simulate cognitive processes Kelly's going to use to develop this AI system. But then we start to think about realistic context. Let's say, oh, Kelly's boss is really on their back, and so they have this time pressure, and so extra stress from the time pressure. And because of this time pressure and wanting to get this AI system completed, they're getting little sleep. So they have sleep deprivation, another form of stress. And because they're tired and they like the taste of coffee, they're getting lots of caffeine along the way. So this is adding on as well. And because we like to torture Kelly, I guess, they're also dealing with heat stress because in the middle of a pandemic and their AC system can't get fixed. So we might start to think, okay, well, how do we begin to think about all these different influences, these different contexts together as one, and begin to think about how we would simulate and model such things. But that's right. We're also worried about AI, the fact that AI is being deployed and used in existing social cultural context. So we could be worried about that. We probably should. So let's say Nods might have to interact with Chris, this theoretical Black man from a financially poor family. And Nods, this AI is not only interacting with them, but they are informed in terms of knowledge system and goals they might have by the developer Kelly. And so one question that I'm starting to think about, well, I've thought about different parts of this, but I'm thinking about now with this whole perspective, how might we go about modeling all these factors and understand implications of this model in simulation, right? Very natural for this crowd. And so when we think about this, I've begun to think about this and organize this in my head and using this figure. And right, these figures are fairly simple. We draw them out, but it's always like pulling nails, trying to actually get us to draw them sometimes. And so I pulled this out and I use this to kind of ground and start to think about these different aspects. And I walk around this figure a bit today to talk about different things and hurry through some things so that we have a bit of time for questions and we can get to the panel as well. And so focusing first on the human agents part, very natural, of course, for this crowd. I tend to think about it physio-effective cognitive agents and modeling in Akdar Phi, the architecture extended version of Akdar that I've been developing. And so I'll go a little bit in a background in Akdar Phi and just give you a mind for some of the different portions of it and where they come from, the different theoretical perspectives. And so the physiological side of that comes from HUMOD, Physiological Model Simulation System by Robert Hester and colleagues. HUMOD has a couple of nice properties about it. It's integrative, so it's we can avoid micro-computational models of physiology, which are useful, but don't allow us to look at full systematic changes. Top-down organization is useful, particularly as we begin to look at existing data, especially from those that are related to a lot of times physiological psychology, where the representations tend to be about the same. So they allow us to really look at the fact that this is an open source model and verify and validate certain aspects of the model, and also modify it if needed, right? And focus on certain things. And I've modified different parts of it for some of my modeling work. And maybe most important, not always appreciated in research, is it's software that works, right? It's available to use and picked up and messed with and messed up in different ways, so that you can verify that it works as it says it works, and also use it in some ways. And it has a bit of a learning curve, but colleagues and I have developed a manual, which hopefully be helpful if you need it, and just ask offline or even at some point, and I can give you that. And what HUMOD, being open source, allows us to do is to make certain diagrams like this. In this particular diagram, the details aren't really important. What we did with this was we looked at heat stress and what happens in the model when you change temperature and humidity, right? What are some of the first order variables that are affected? And what does this mean for some of the other variables in the body, right? And then we can start looking at downstream effects, right? And so when we can start looking at downstream effects, we can start to think about what that means for cognitive processes, particularly those, as we look at those connected neurological circuits and how these circuits are affected by those physiological variables. So that's HUMOD, big as a system as it is. That's the physiology. The affect emotion, Akdar-Phi, tends to be represented with Jack Panks's primary process affect theory. It also uses other theoretical perspectives, but that is a real grounding in the system. And in Akdar-Phi, particularly, we focused on seeking and fear for some practical reasons. And what's nice about this is it has a certain connection to neurological circuits that allows us to move up from what Panks would call primary process level to looking at things like cognitive level processes and start to connect to some of those other neurological circuits, particularly in Akdar's perspective, where we also see some of those connections, and as well as when we look at Andrei Stackel's work with the common model of cognition, right? It also relates to some of that, which is nice. And then when you're looking at the some of these connections between secondary and primary process level, we can also bring in work like Ken Berridge's lab, where they're looking at computational models of reinforcement learning and how those may occur in the brain and how they may connect to different effective processes, right? Lots of from a systems engineering perspective, lots of places to connect and lots of places to pull in these theoretical perspectives to make our architecture, to extend the architecture. Now, we're pulling this together. Akdar is the kind of the base on which a lot of this is extended. And this is just, one figure of many of Akdar, different ways to draw it. The figure's kind of drawn this way because of what the focus of Akdar-Phi is. And with Akdar-Phi, the focus on, what's affected within Akdar tends to be some symbolic, at least right now. And so reinforcement learning, utility learning, right? So we can connect reinforcement learning in Akdar, for example, to Ken Berridge's work, to Jacques Panks' work, the whole way down from the neurological circuit up to a functional representation. And we can do the same thing with declared memory system, using Akdar's existing systems to think about that, especially for my work as it connects to stress and arousal, right? So there are lots of connections there and more to be made in some ways. And I'm contractually obligated as a former advisee of Frank Ritter to give his plug here for one of his overviews, one of his articles that can be useful for just high level understanding of Akdar. Of course, there are books to be written, as Christian might know, on Akdar. And so, but if you want a shorter article, this can be useful as a start. In terms of affect and emotion architectures, there's been plenty of work, a good amount of work. I wouldn't say plenty of work. You have Sigma, you have another version of Akdar, focusing more on core affect, kind of a different level of analysis for emotion. And really, some colleagues and I have worked on kind of an overview paper for these different approaches, which can be useful. And we've based on some of the work from coming out of the Common Model of Cognition or Standard Model of Mind Symposium. So look out for that paper if you're especially interested in some existing approaches, and using that as a good use as a start. So Akdar-Phi itself uses these physiological and neurological connections to really think about the functional connections that should be added, right? And a painstaking process in many ways. But what this allows us to do is to really make these functional connections between HUMOD and Akdar in ways that not only fit well with what we think is happening, but what fits well from the cognitive level as well as from the physiological level, right? What's reasonable and what actually might work, because we know that there are certain connections between physiological and neurological processes, of course, all is one system. And there's work abound on the connections between some of these systems, which allows us to really stipulate these connections. And some of those references are in Dancy's 2019 paper, and I can provide that again if you ask, and I'll give a reference slide at the end. So in terms of models, Akdar-Phi has plenty of models, enough models to begin to explore some of these different aspects, focusing a bit more of the emotion aspects, some focusing a bit more of the physiological perspective, and some combining a bit more. For the slow breathing work and sleep deprivation work, we've actually, and also the heat stress work, well, not the heat stress work, we haven't modified HUMOD, we've used it quite a bit, but for the slow breathing and the sleep deprivation, we've actually extended HUMOD a bit to add in some of the dynamics of slow breathing, which weren't there because of the way HUMOD's built. and also for sleep deprivation, adding circadian rhythms and sleep homeostasis, which weren't there because of the focus tends to be of humans. So we've used existing mathematical models and pulled them in. And so coming back to this example, right, we're thinking about the individual level, the physiological perspectives, but what about even from the individual level, thinking about the sociocultural perspective? Well, this relates to a study that still is actually ongoing, where we're looking at, originally we were really looking at the effects of stress and human cooperation using a version of the stack hunt task called the pig chase task. This task was developed by Microsoft Research for a summer research competition. So we used that, and there are a couple of practical reasons why we ended up using that version of the task. One of the reasons being that we're using Minecraft quite a bit within my lab and at Bucknell. And so with this, we have a computational modeling component, which I'll show a little bit of a video on, just the model moving around. And then we also have a human experiment component using physiological sensors along with some behavioral measures along the way. And so we have this model, which actually this video is a bit old at this point, but Koi Lam should get a special shout out. So I kept the video in. We have a model that's updated where it moves around the board and it moves much faster than is in this video now that Koi's gotten past some of the technical difficulties that he was encountering early on. And so Koi Lam right now is working on a model still within the pig chase task, updating it, making it a bit more sophisticated. And so we're still working on that. Now for the experiment part, one issue we ran into when we were trying to begin to collect data during March of 2020 is that COVID hit right when we were going to start running this study and collecting these physiological data from these physiological sensors. And while it was possible, and I thought of a few scenarios where we could pull up a protocol that would probably work for what I wanted to do. Given that I wasn't willing to run the experiment myself, I wasn't going to have my undergrad RAs run the experiment. So what we've done is we've changed a little bit. We've gone from the physiological to the social and focused on that aspect a bit more. And so what we did was we created another version of our experiment. With part of this was funded by an RAU, and Nikhil Atkins has worked on this. He's been great now. So I had a postbac funded by that same NSF grant, working on this Matt Brown. And so what we did was we took that same pig chase task, and instead we, drawing on some of the work by people like Steve Cave, looking at the inherent racialization of AI agents and AI systems, we added a small treatment to the pig chase task where the participants are led to believe, a very small treatment, where they're led to believe that the AI was trained on either predominantly white population, predominantly Black population, or that it was just trained, right? It's just, and really it's mentioned in the instructions, right? Oh, by the way, this was trained on this population is one of the last things. Now, one thing I didn't mention with pig chase and as a cooperating task, in order to get the highest score in this task, really you have to cooperate with the other agent, right? And so if you want to score as high of a score as possible, you have to work with the agent, or you can get a kind of a lower score or get closer to, not a net positive, if nothing else, if you decide to just exit the task and, get whatever small amount of points you can get. And so when we looked at the score and the participant behavior across tasks, we do see some interesting patterns from our initial experiment. So what we see is when we look at the treatment group for the Black African-American, they said that they were told that the AI was trained on predominantly Black and African-American population, both demographics. So I guess one thing that we did with this was we balanced those who self-identified as white and those who self-identified as Black with this experiment. And so within that interaction, those identify as white and Black, and the treatment group for the Black treatment group, what we saw was the actual behavior, the performance on the task was about the same. You see I as very much confidence intervals, which is what the shaded area is. The confidence intervals very much so were overlapping throughout the course of the task. And the averages, the running averages across the trials also stayed about the same. What interesting thing we see with this study particularly is when we start to look at not only the other treatment groups. So we look at next, we go down to the white treatment group, we see a bit of a deviation in performance and the running average of the score. across the course of the task. And still overlapping CIs, but we see much more of a deviation than what we saw with the Black treatment group. And then when we look at the control condition, the just regular condition, we see a full separation of our confidence intervals, and the scores, of course, just taking a different pattern. And when we look at this overall, so the farthest to my left picture, the average cumulative score per trial for all of the groups, we look at it whole, what we see is with the white treatment group and the Black treatment group, we see kind of a mirrored reflection. So in the Black treatment group, those participants did the best, the Black demographic, those participants did the best in the Black treatment group. And in the white demographic, those participants did the worst in the Black treatment group. So we're still trying to tease apart this and run some follow-up studies to understand some of the behavioral parts of this. And we're pulling some of the behavioral sequences from this as well to really understand what's going on. And we look at some of the qualitative data we collected via surveys after. When we look at the way they regarded the AI agents, what we also see that's interesting is we look at kind of categorizing their responses to the way they thought the AI behaved. We see particularly higher numbers in comparison to the white treatment group and German treatment group, AI not intelligent, them classifying the AI as not being intelligent, or thinking that the AI worked against them, right? And trying to judge the way that AI worked. And then if you look at AI had no pattern as well, which can be looked at as not intelligent as well, we see a particularly high number. Now, what's interesting about the qualitative data is among the Black participants, this was actually, the proportions were fairly consistent between all the treatment groups. This is really driven by the white participants having a much higher negative sway towards the AI agents in the Black treatment group. So what we're trying to do, given that we kind of saw some interesting results early on with this kind of initial experiment, is start to model some of the memory processes here to understand where we might change the treatment, because it's actually a very small treatment in the task, to maybe have a bit more of an effect, especially as we scale up, but also in a way that doesn't change how they view the experiment. And one of the reasons why we had a small treatment there was we didn't want to influence too much how they impacted the experiment explicitly. We wanted to explore some of the implicit parts of some of the subsymbolic perspectives of these racial effects or racial beliefs on the cooperation. So it's interesting individual level stuff there, right? Interesting stuff to continue to model and experiment as we're moving through. And then when we start to look at it from a sociocultural perspective, I'm starting to take some work from Frans Fanon, but also Sylvia Winter in thinking through sociocultural structures. And I'll kind of, I'm going to skip this in the name of time to make sure that we have plenty of time. But one thing that Sylvia Winter talks about in some of her work, particularly the 2003 paper, is this idea of the space of otherness. And she does a nice historical lesson on how we moved from defining people who are other or less than human, first based on religion, and then based on this idea of rationality and irrationality, right? Going from those who were in the right religion to those who are just irrational. And then we moved from that being biological to that being cultural, right? Cultural deficit for intelligence or rationality. And of course, we want to be difference there, not deficit. And so the questions that start to come to mind as I think about this idea that Sylvia Winter brings forward with space of otherness and what she calls the genre of the human. How do our social structures enforce a standard? How do you enforce an order or hierarchy? This is also particularly interesting when we think about the term intelligence and where that term comes from and historical references to intelligence. What do social structures mean really for design, development, testing, and deployment of these AI and cognitive systems, right? Thinking about that whole process. And what does our current, what Sylvia Winter calls genre of the human mean for those who are regarded as other, right? In the context of that above question and in this general discussion of humanity. And so we start to think about, as a colleague and I argue in the paper that we have under revision right now, after review, this idea that these AI systems that we have and that we create not only draw from the environment, but they perpetuate some of these racialized power dynamics and add to that environment, right? Because we're in very much so a digital environment these days. So this relates to, for example, some of Safia Noble's work where she looks at and describes work about taking a critical perspective on how search engines can enforce and perpetuate certain oppressive views. And Google is a great example, and search engines are a great example because we know that we become dependent on some of these types of systems in the same way that we might be dependent on knowledge from friends and family, right? These social knowledge repositories are now become digital and online in many ways. And so this is important for thinking about how our own environment is constructed based with these AI systems that create a sort of bootstrapping process. And then when we think about the developer, we think about the idea that the goals of the system that's created is defined by these people, these human agents, and who come from and operate within this racialized environment. And so I wanted to explore this a little bit and do a quick audit of an existing system, knowledge graph. I came across ConceptNet, this kind of big multilingual knowledge graph, which is really nice because it pulls from its knowledge from several sources, right? And so the idea here was to begin to explore, what does it mean that we have this digital environment? And ConceptNet itself has this system called Number Batch, which you can use. It's a word embedding system, and you can use it to really understand relatedness between terms, right? Within their giant knowledge graph, as well as with other knowledge sources actually beyond ConceptNet. And when I did this kind of this initial audit, I wanted to look at how humanity related and animal terms might be related to racialized terms for man and woman. And so we come up with something like this heat map when we look at the relatedness between different terms. And so the lighter the intersection, the more related they are within the ConceptNet 5.7. And so we look, what's interesting here is man in general, right? It has a lot of connections within the system. So it's kind of related to a lot of different things, which isn't surprising. But when we look at the racialized version of man, we see an interesting thing when we look at animalistic terms versus terms more related to humanity. We see that Black man tends to be more related to man when it comes to animalistic terms, but it's less related to man when it comes to human related terms. Now, when we think about intersectionality and gender, we also get some interesting results that are just different, right? And intersectionality and a lot of that theory would tell us that they're going to be different in certain ways because of aspects of social intersectionality. And so we look at woman, what we see is white woman is actually almost exact copy of woman. But Black woman actually is, within this system, is not related to anything. And that's because Black woman actually doesn't exist, right? It's really an interpolation process they've used to determine the relatedness with Black woman. And so what's interesting there is ConceptNet itself has already been debiased, right? If you follow the AI society and AI ethics literature, they have this idea of debiasing. And so it's also already gone through a process of debiasing. And so one thing I'd be interested in doing is going back and looking at what previous versions look like to see if the debiasing actually erased Black women from this. And it's interesting because when we look at intersectionality literature, one of the big things is erasure of Black womanhood. So that's an interesting kind of initial audit before we even get to more sophisticated versions of that audit. And so back to this example, right? We're thinking through design, the fact that we have this developer, and we might have these initial questions on simulating and modeling, but then we're thinking about the fact that the AI system will interact with many people, not only Chris. And so we started to think about how will design for a standard user ignore sociocultural context of Chris? What will it mean to think the design in terms of values and resources? And I brought up Simon because he talks about this in his book, but also because he brings up highways as an example, which is particularly interesting given that highways were built through African-American communities and destroyed them quite explicitly when a lot of our highway systems were built. So that's an interesting perspective considering values and resources, whether it was because there was intention value in destroying the community or there just wasn't a value in that community at all. And then from the cognitive modeling perspective, we can start to think about ConceptNet and the declarative memory system, right? Think about what that means for our models and our architectures, particularly as we think about questions like what choices should a model or a person make in deploying the AI system, what's the next goal? And then if we think about things like not only debiasing AI systems, but also diversity trainings, which tend to be rely on very explicit monitoring, what that means given that we have these stressors, and they tend to result in us using implicit subsymbolic processes, right? And that means the explicit monitoring becomes very difficult. And so what does that mean, given that we have this background environment and knowledge system? And I always forget that animation. So that's the social culture part I've been thinking about, making my life as easy as possible as I think about all this. And kind of the last slide, I started to think about these questions, like how do we continue, but avoid a particular mode of being human? How do we realistically engage with these technological changes? Modeling and simulation is one way, right? Given that our environment now is very much so digital. And then how do we avoid a project that enacts the dominant mode of the human and uses, and to use Ruha Benjamin's term, contributes as a colonizing project. And so, yeah, I'm over time already. I'm sorry, Christian. So this is kind of what I've been thinking about, not only at the physiological and individual level now, but also thinking about how some of those top-down processes and background knowledge systems affect the way we operate and what that means for human AI interaction particularly. Various funding sources with this, and also some help from, of course, my own lab, but also the ACS lab, and giving some feedback on this talk. And here's a reference slide. Feel free to ask for it. I can send you a PDF of it if you're interested in any of the people referenced there. Then, okay.
Thank you. We have time for a couple of quick questions before moving on to panel discussion. The first one is Pat Langley asked if you distinguish between affect and emotion.
I have always seen affect as the kind of the neurological perspective, or neurophysiological perspective. And I view emotion as the combination of affect and cognitive processes. That would be my short answer. And I think to me, that's always the way it's been used. Every once in a while, it gets kind of conflated, but particularly drawing on Jaak Panksepp's theory and some of the related theories from neuroscience, affect tends to mean a bit of a different thing than emotion does. And I think that's where actually some of the arguments come from, where that just kind of gets overlooked.
Thank you. Then the last question before we move on to panel discussion from Andrea. I really like how your approach expands the idea of cognitive architecture vertically, upwards to the social and downwards to the physiological. How did this change the way you think about the middle level cognition? And I think you obviously touched, that was an early question, and you touched to some of that later in your talk, but if you can elaborate on that.
So I think one of the things that's had me question more is how simple of tasks I want to approach and use in my analysis and confirmation of processes, right? And the reason I say that is because the social approach and top-down perspective would tell us that some of the things that we do are kind of inherently driven by those social processes, right? And the long scale of and long temporal scale of social processes. And so I've tried to really critically approach the tasks I use and what I'm focused on based on that sociological perspective and physiological perspective, right? Thinking about that. So in some ways I ignore it sometimes just to make my life easier, if I'm honest, but really it just gives me more heartburn. I basically give myself more of an opportunity to get heartburn on everything I do, because I know it's all missing these levels at some perspective. And so I think it's just changed my end goal and what I'm moving towards.